Welcome back, guys. It's Marlon Echeverry from the Natural and Social Science Tutoring Lab here at Miami-Dade College Kendall campus. Today we're going to be looking at what are known as double replacement reactions. Let's go ahead and take a look at what a typical question would look like from a double replacement reaction. So they might give you something like this, where it says complete and balance the following react equation. Here you have sodium sulfate, and then you also have this other compound, strontium chlorate. They're reacting, and your task is to go ahead and figure out what the products are going to be, and you're also supposed to figure out how to balance this equation. A lot of students, when they encounter double replacement reactions, they get really intimidated because they don't know how to start the reaction. Really, it's just a matter of 4 simple steps that you just have to follow. Let's go ahead and look at the first step and try to look at some of the details for the first step. So, step 1 is what is known as rearrangement, where you're trying to rearrange the molecule that are involved in the reaction. So you have compound A and B, and then you have compound C and D. And typically this is composed of an element and a polyatomic, or just 2 elements that are combined. They're going to break apart and they're going to switch partners. So for example, A will recombine with D to form product AD. Similarly, in the other 2 elements, you're going to have C recombining with B. Now, a question a lot of students like to ask is, why does it have to be in the format of element C and then B? Why can't it be BC? Well, the idea is that the positive element always has to go first, and then the negative element. So it's always going to be C and then B combining into a compound. So let's go over some of the basic rules for rearrangement. If you're bringing over an element, just a regular element, then you simply bring over the element. There are no subscripts that are to be brought over to the right side of the equation. If you're bringing over a polyatomic molecule, though, something like nitrate, NO3-1, then only bring over the subscripts on the inside of the parentheses to the right side of the equation. So let's look at what I'm talking about. Let's take a look at our example again and try to actually work this equation. So here in our problem, we have sodium with a little subscript of 2, and I have sulfate here with SO and a subscript of 4. And then over here I have strontium, and then I have chlorate with a subscript of 3 on the inside of the parentheses, and a subscript of 2 on the outside. What you want to do is you want to take your sodium, and you want to go ahead and recombine that. So let's go ahead and do that. So I'm going to go ahead and take my sodium, and I'm going to go ahead and recombine that with the chlorate. I like to sometimes think of it as the elements on the outside that are reacting. So on the right side of my equation, I would simply write sodium. I'm not going to put a subscript because it's just an element, so I'm not bringing over this little 2 because it's just sodium. And then for the chlorate, I'm only going to bring over the 3 because that's the subscript on the inside of the parentheses. So then this will become ClO3. How about for the second compound? Well, for the second compound, let's go ahead and change colors. Let's go ahead and pick, I don't know, how about red? So I'm going to take my sulfate, and I'm going to go ahead and recombine that with strontium. I like to think of this as the elements on the inside. So when I rewrite this though on the right side, I have to make sure that I go ahead and I put strontium first, because that's the positive element, and then I'm going to go ahead and put my sulfate. I'm going to go ahead and put the SO4. Now, a lot of students like to ask me, why did I bring over this little 4 when over here it doesn't look like it's on the inside of parentheses? But you have to remember that there's actually an invisible 1 surrounding that sulfate, in the same sense that there's actually an invisible 1 around the below the strontium. So really, all I'm doing is bringing over the 4 because it's on the inside of the parentheses. So you would end up with something like sodium chlorate and strontium sulfate. Let's go ahead and look at the second example that I have here. Here, I have iron acetate reacting with ammonium phosphate. Now there's a lot of polyatomics in here, and this can intimidate a lot of students, but don't let it. This is just C2H3O2 with a little subscript of 3 on the outside. But I don't care about the 3 because I'm not going to bring that. It's on the outside. And then here I have ammonium, which is NH4, with another little 3 on the outside, which I'm also not going to bring over because it's on the outside of the parentheses. So let's go ahead and start rearranging our compounds here. I'm going to take my iron and I'm going to react that with the phosphate. On the right side of my equation, I'm going to go ahead and write iron and phosphate, PO4, for the first compound. For the second one, go ahead and keep the color scheme that we had before. So I'm going to pick red again. I'm going to take my acetate molecule here and I'm going to react it with ammonium. I have to remember to put the positive element first, so I'm going to go ahead and put NH4, and then I'm going to go ahead and put the acetate, and then you have to write the whole thing out. So it would be C2H3O2. And this would be completing the first step in a double replacement reaction, which is to correctly rearrange the molecules. In the next video, we'll go ahead and start doing step 2, which is crisscrossing your product charges, so we can see what are some of the new subscripts that might emerge. Thank you, and I hope it's been helpful.